Hi, welcome to the lab 1 of CE305 Languages and Compiler. So today we'll be going through some of the setup that you would need for your lab so that you can successfully start working on the language that you need to develop. Just let me check if it is recording. Yes, so it is recording successfully and we will continue. So before we proceed, if you can recall, we already mentioned in the previous lecture of Unit 1 that a compiler has traditionally two parts, the front end and the back end. Now, let's take a step back and realize what a language is. A language is something very much like our English language that you need to define based on a set of rules. So your language has to follow some rules or else it cannot be understood. These set of rules can be thought as grammar. Now, now that we know that what is a language and what is a grammar in brief, let's go back to compilation stages of a compiler. As you already know that a compiler has the front end and the back end. So here we are going to learn the techniques of the modern compiler. Now, modern compiler consists of the front end and back end. In the front end, we have steps, which is lexical analysis, syntax analysis, and semantic analysis. In the back end, we have the steps which are intermediate code generation, and machine-independent optimization. So once your language is defined through your grammar and you write code using the grammar and your defined language, then the code is actually processed in the front end of the compiler by the lexical analysis stage. In the lexical analysis stage, basically the compiler scans through your code to create symbols, or they are also called tokens. Then the token is processed by syntax analysis, or also called parsing, to create parse trees. Parse trees are more or less like data structure which kind of matches your grammar with the input code. And after the parsing, your parse tree is processed by the static semantic analysis to create a more optimized parse tree. From the parse tree, intermediate code can be generated, which is then further optimized, and machine level code is generated based on the hardware or system that it is going to run onto. So this lab is a short tour of this compilation process. If you do not understand most of these topics, do not panic or do not feel overwhelmed, as in the next lectures in the following weeks, we will be going through each of these topics to get a deeper understanding of what is happening in each stages. This lab lecture also provides a general overview of ANTLR's capability for the lab session. Now, shortly we will be exploring what is ANTLR, but it is one of the most important tools that you will be using as part of developing your own language and building your own compiler. Let's now look at the lexical analysis and parsing phase. So parsing is much easier to be understandable if we break it down into two stages or two tasks. So the first task is the process of grouping characters into words or symbols, which are called tokens. So this process of creating token is called lexical analysis, or simply it's also called tokenizing. Here, the tokens can be integers, ID or identifiers, or also floating point numbers, and many more. Now, we call a program that tokenizes the input as lexer. In the second stage, this is after the tokens are created by the lexer from your input language. So in the second stage, which is actually called parser, the parser feeds off on these tokens to recognize the sentence structure and create parse trees. Parse trees are the data structure representing how a grammar matches the input. Now, let's take for an example here. So here we have the code SP equal 100 semicolon. So the input here can be seen as SP equal 100 semicolon. So here it means that 100 is being initialized or assigned to the variable SP. If the input is this one, then the input is being processed by the lexer to form tokens. Here, from this code, the tokens are SP equal 100 and semicolon. Each of these are tokens. Once the tokens are created by the lexer, then the tokens are processed by the parser. And the parser then creates the parse tree, which is shown by the structure here. As you can see here, it forms a data structure in such a way that using hierarchy, that the parse tree actually represents the input code based on the grammar that you have defined as part of your language definition. Now, let's look at ANTLR, which you will be heavily using for your lab. ANTLR stands for another tool for language recognition, which is created by Terence Parr. The current version of ANTLR is version 4. So it's called ANTLR v4, which is a very powerful parser generator that you can use to read, process, execute, or translate structured text or binary files. ANTLR is widely used in academia and industry to build all sorts of languages, tools, and frameworks. From a formal language description, which is called the grammar, or it's the set of rules that your language has to follow, ANTLR generates a parser for that language that can automatically build parse trees, which are again the data structures representing how a grammar matches the input. ANTLR also automatically generates tree walkers that you can use to visit the nodes of those trees to execute application-specific code. What does that mean? So tree walker is something like, for example, if you take this as the parse tree, so the tree walker will go from each node in the tree, and then it will generate an output which could be seen for used for different cases. One of which being generating the intermediate code representation, which will be then processed by the backend of your compiler. So let's look at the ANTLR workflow that actually happens behind the scene when you start using ANTLR with Java for your lab. So the first thing that happens using ANTLR, you first have to define the grammar for your language. So after the grammar is defined in the ANTLR, ANTLR generates Lexer, parser, and visitor. Now, these can be thought as classes in Java that do specific tasks. Now, let's see, after Lexer, parser, and visitor are created or generated by ANTLR using your grammar, what happens? So, the input string is, as you can recall from the previous slide, input string can be something like SP equal 100 semicolon. So the input string will be then processed by the Lexer to generate tokens. And then the tokens are processed by the parser to generate the parse tree. And the parse tree can be then processed by the visitor to create an output, which could be used in various different ways. One of which was again being further processed by the backend of the compiler. But as you can see, ANTLR can easily help you develop the parse tree, or it can actually help you do lexical analysis and semantic analysis very easily to finally generate an output which can be a parse tree for further processing. Now, since right now we have covered the brief understanding of ANTLR and how to work with it, let's move into the practical to finally get our hands dirty and do some coding to generate parse tree on our own. So first of all, move to your Moodle. Let's move on to Moodle so that we can set up ANTLR correctly for your Java programming. If you go to Moodle for your module CE305, and if you scroll down, you will see there's a section called ANTLR. If you click on it, you will find there are relevant resources specifically for ANTLR that you can review, and you can also download the setup that is required. So if you click on this ANTLR, you will actually be redirected to another page where you can find the official website of ANTLR project. If you click on that, the official website will look something like this. Do not worry, here it actually, when you are on the main page of the official website of ANTLR, it actually tells you to set up using command line or command prompt, but there is far easier way. And if you do not know command prompt, then you do not have to worry, because right now I will be showing you how to do it in easily, just by downloading a couple of files and then setting it up. So on this website, you will find on the menu, there is an option for download. If you click on download, then you can see here, ANTLR is actually supported for several different languages. Java is one of them, C#, Python, JavaScript, and many more. But because we will be using Java, so we will be only focused on the installation for Java itself. Now on this page, download page, if you scroll down, and you can see here that the line which says ANTLR tool and Java target. So here the first link will be complete ANTLR 4.9.3 Java binaries jar. You need to click on it and it will start a download that you need to save on your computer. Now, I have already downloaded. I won't be doing the download right now again, but you have to download the file from here. After you have downloaded, now let's move on to setting up your Java environment. If you're using Horizon of CSE, it would work the same way, because for our Java programming, we will be using an IDE called IntelliJ. Now, on your Horizon, if you, especially Horizon Windows, if you search for IntelliJ, you should be able to find the app or the application like this. Again, if it is for your own personal computer, then you do have to download IntelliJ separately if you haven't done it already, or if you do not have it installed on your personal computer. But if you are using Horizon, this should already be installed, and the Java should also be set up correctly with the IDE. So you do not have to worry about that. Now, when you click on it, it should open up your IntelliJ like it should look something similar to this. Here, you actually need to create a new project so that you can work on your lab. The new project, you have to click on the file from the menu, select a new, and then project. Once you click on project, do make sure that the project SDK is pointing to the right JDK or Java Development Kit, which will be used to compile your Java program. Now, if you are on Horizon, this should already be there correctly, and you do not have to worry about any of these setup at least, but do make sure that the JDK is selected. After that, click on the button next. Then after you click on the button next, then you will see that here it will give you options like create project from template, but do not select that. You continue by selecting on next, and here you have to define the project name. Now, let's say I call it something expression. So after you have provided the project name, then click on finish, and it should actually create something very similar to as you are seeing now. On the left hand side, you will see it shows the project directory, which is called expression. If you expand it, here you can see a similar structure to here, out folder, SRC, which is the source folder where you have to actually write your own program. Now, once you have reached this stage, let's set up the ANTLR. In order to set up ANTLR, you actually have to click on the file from the menu of your IntelliJ IDE. And then first thing that you have to do is give me 1 second. Yes. So you have to create on project structure, and then you should see something very similar to this. In the project structure, select the libraries and then click on this plus. Here you actually have to add the ANTLR jar file that we have downloaded earlier from the website. So select the, click on the plus, select Java, and then select the folder where your ANTLR was downloaded. And if you click on OK, then it should actually add your ANTLR jar file, something like this. And after you have added the ANTLR jar as library, click on the apply and then click on OK. This actually installs all the necessary like dependencies or libraries of the ANTLR so that you can build your own program using Java on your own. The other thing that you need to do is again click on the file, and here click on file from the menu of your IntelliJ IDEA and then click on settings. Once you reach settings, you should see something like this. Here you will have several different options, but click on plugins. After you have clicked on plugins, here you will be able to search for the plugin called ANTLR, ANTLR. And it should show you an option something like this. So this plugin is needed to get the GUI side of the ANTLR so that you can do prototyping of your language faster. And I will be showing you how to use this shortly as well. So when you found this option from the plugins, click on install, but I have already installed on my PC. So I do not have to worry. But if you are using Horizon, you might need to install ANTLR. Install the plugin of ANTLR. So do install, and after it has been installed, click on the apply and then click on OK. Now we have set up everything that you need to make ANTLR work with your Java program. So let's create an example. So the example that we are going to create is, let's define the grammar to parse expression. Expression can be something like 100 plus 2 multiplied by 3. This can be thought as an expression. So this one needs to be processed by your grammar to provide the parse tree or to generate the parse tree. The way we will do that, first click on the SRC, or that's the source directory of your project that where you need to write your grammar file. So click on the SRC and then right click, and from the right click you will find the option to create a new file. So once you create new file, now give it a name something like expr.g4. Now keep in mind, .g4 is the extension which signifies grammar file for ANTLR. So this is the grammar file. Then when you click enter, you will see ANTLR should create a file which should be initially blank, something like this. And this is the grammar file for the expression analyzer. The grammar that we have to set for the this expression analyzer, so it can be defined like this. Now I have actually copy pasted this beginning of the code from the ANTLR's website. So if you go to ANTLR's website to the main page, and as you can see, if you go to samples, click on samples, you will see this is the same expression analyzer grammar that you can use. So I have copy pasted this into my IDE, but I have actually added these two lines here. Now, so this one first, of course, is the comment, but what this line as part of the grammar does, it actually ignores any form of white spaces. White spaces could be a space, tab, carriage return on new line, those type of things. So here, when you provide an like expression like 10 plus 2 minus 3, that will be processed using this grammar to ultimately generate the parse tree. Now, if you have reached this stage, save the file. After you have saved the file, here you have to set up another thing. The first thing that you have to set up is make sure that your expr.g4 is selected, or your grammar file is selected, and then go to menu and click on tools. When you click on tools, you will find there's an option called configure ANTLR. Click on the ANTLR. Here in the first line, most probably it will be blank when you open it up for the first time, but do make sure that actually the output directory of which is mentioned here needs to be this source file. So create that, put the path or fill up the path here as the output directory, which is the source file directory itself. And also make sure that here generate parse tree listener is selected, as well as generate parse tree visitor is also selected. And then click on OK. Now, let's quickly look now that this is set up. So your ANTLR tool is now configured correctly for this project. Now that this is set up correctly, let's test if this grammar is working as we like for expression analysis as we think. So when you're on the grammar file, right click and you will find the options here. Okay, before you do that, you have to do another step that I have forgotten. That step is when you're on the grammar file, click on the file, right click on the file. Here, you will find an option called Generate ANTLR Recognizer. Click on the Generate ANTLR Recognizer, and you will see a lot of files are created. Now, these are already the files that, if you can recall, the Lexer, parser, visitor. So these are already code that are created in Java by ANTLR automatically. Now, once these files are created, open up your grammar file, which is here. And now from the file section, create a new Java file or Java class. When you click on this Java class, name it something like main parser, and then hit enter. Once you do that, you will find you have a file something like this. It would not even have these import options as well, but something like this. So here you have to code in Java to create the parser or the parse tree. The way you can do it, I have already written the code, which will be something like this. So now if you, as I follow along, if you have to pause and write your code accordingly, then you can do that. But let me go through each line of code. Here in the first line, which is the character stream. Here we are actually taking reading character from a file which is called test.cc, and that character has our expression input. Once the character is read, then we are creating the lexer by, as you can already see, that the lexer, which is automatically generated by ANTLR, it's called EXPR lexer. So you have to use that class to create the lexer object here. After you have created the lexer object, from the lexer, you have to create the tokens from the input file, which we are processing from here. So this line, the common token stream, actually creates token, and then the token needs to be processed by the parser. Again, the EXPR parser is here. It's a Java class which is automatically created by ANTLR. And then after you have created the parser, you have to create the parse tree by using this line of code. Now, after the parse tree is created, then you can just print out the value of the parse tree using this line of code. And if you run now, if you have reached till this point, if you run the code, you can see you will get the parse tree. Now, sorry, I forgot to mention. So I have separately also created a file, which is the test.cc file, which actually has the input. Now you can again create the cc the input file using new go to file on the menu, click on new, and here you will be able to generate file, name it something like test.cc, and the content of the cc will be an expression which is like this: 100 plus 4 multiplied by 7. So this is the expression that ANTLR is actually processing to generate the parse tree. Now here, this parse tree, the output of the main file, is is the parse tree that is shown here. So hope this helps. Play around with different grammar and what you can do with it, and we will see you in the lab.